Okay, so we are still sort of in definition mode, even though we're on lesson 4 of vectors. You might be able to see how there's applications to this particular topic, but I haven't labeled this because even though it's an application, it's more of a thinking question than an application question, meaning that I don't know if you'd ever actually use this stuff in real life. So it's more in the realm of definition. So we're going to talk about scalar multiplication in this note, and this is defined as multiplying vectors by scalars. So multiplying a directed line segment by a regular number. And again, I've said that this is infinitely cloned, meaning that I can make as many u's as I want by just pulling it off. So vector u below, so this guy right here, for vector u below, explain how you would sketch 3u. So here is how you would sketch 3u. You would take u, and you would take another u and tip to tail it, and you would take another u and you would tip to tail it, so that you've got 3 u's lined up going in the exact same direction, and that is 3u. Now, I am going to have some difficulty showing you negative 5u, but I'm going to do my best job possible. When I talk about negative 5u, I need to take 5 u's. So 1, 2, 3, put them tip to tail. 4, and my 5th, and that isn't negative 5u. That is 5u. So I'm going to write that in red because that's a red vector. As I said, it's not negative 5u, it's positive 5u. Here is negative 5u. There it is. So as you can see, it's the same length as 5u, but it's opposite in direction. So I hope that's pretty easy. Now we're going to look at more kind of properties. So for vector u, so whatever vector u it is, not specifically the one on the last page, and a real number or scalar, that's k, so u has the vector hat on it and k does not. K multiplied by vector u is also a vector with the following characteristics. The magnitude, found myself a typo. The magnitude of k times u, vector u equals the absolute value of k times the magnitude of u. So basically what that's saying is that if you take a vector u and you multiply it by a regular number and you find the magnitude of that, so you find the length of that resulting vector, that is the exact same thing as finding the magnitude of the little vector and the positive value of k and multiplying them together. The directions of u, vector u, and k multiplied by vector u are the same when k is greater than 0. So that is this example. So this example, A, there is vector 3u, as best as I can draw it. And I'm going to turn it into a red vector so that it matches. So because 3 was a positive value, that means that 3u is going in the exact same direction as u was originally. As opposed to when I multiply it by a negative value, I have this distance here is exactly the same as this distance, And it doesn't matter what the direction is. So it's 5 times whatever the original distance was. And k multiplied by vector u is called a scalar multiple of vector u. U and k vector u are parallel, as you can see with both of these. So I don't know if I actually finished this. I was babbling about it on the other page. When you multiply by a number greater than 0, that means the directions of these two vectors are the same. But if you multiply by a number that is less than 0, then you'll have opposite directions between the original and the k multiplied by the original. So here is an actual question. So a thinking question rather than application. And again, I've infinitely cloned it. So I've decided that this is A and this is B. Those are the directions, those are the lengths. And I had to lock them in so that I didn't swing them around in any direction. So I want to make 3A minus 2B. So this is a sketch. So I'm going to take an A and a second A and a third A. So that's 3A. That's the start of what I need to sketch. And then I need to put on 2 B's going on in the same direction or in opposite directions. So there's a B, and I had to put it that way because really what I want is that poorly drawn, so I'm going to reverse it. And then I need another negative B because I need negative 2 B's. So really what I've drawn, and I'm not going to use a ruler for this, here's 1A, 2 A's, 3 A's going in the positive direction, then a B going in its opposite direction, and a second B going in its opposite direction. So if I erase all that stuff, and technically this is tip to tail, the result is this. So I don't know if I can do this. Not bad. There's my negative 2 B's. So you can see that I start here, and I travel, and I end here, and this is what I'd call the shortcut. That thing actually has a name, and it'll probably come up later, maybe even the next slide, because I haven't checked it in advance. That thing's called the resultant, and it is indicated with an R with a hat on it for resultant. If I want to know the magnitude, so the length of the resultant, I write it like this. All right. Oh, is there more? There's no more. So the next thing is a bit tricky. It's got some math with it in case you have looked at this so far and said, oh, there's no math yet, I'm just drawing pictures. But a unit vector is a vector that has a magnitude or length of 1 unit. So whatever that unit happens to be. Maybe it's a centimeter, maybe it's a meter, maybe it's a kilometer, maybe it's an inch, maybe it's a foot, maybe it's a hand width, maybe it's the length of your forearm. It is just 1 unit long. So the example here is suppose that vector A below, this one that I've made up, has a magnitude of 17 units. So this is 17 units long, not 17 centimeters, just 17 arbitrary units. Explain how to sketch a unit vector in the same direction as A. So we want a teeny little vector that's one of these 17 units long, and I want it to go in the exact same direction. So to answer this question, what you do, get out of there. What you do is you draw, and remember it says explain how to, not to actually do it. Draw a vector in the same direction as vector A. Remember to use your vector hat. But make it 1 over 17. So 1/17 of the original length. So you'd have to split A into 17 little bits and only pick one of them. And that would make a unit vector. So here's the formula for any non-zero vector A. So for any vector of some length, a unit vector in the same direction as A is the vector, and this is a vector because I've got this here without the magnitude. It's 1 over the magnitude of A, 1 over the magnitude of A, multiplied by the vector. So this little bit here is a scalar. And this formula needs to be memorized. So memorize it. So I am going to get that out of there so you can see it clearly. All right, next up, watch the language on this one. We have 3 unit vectors. There's a unit vector, u, a unit vector, v, a unit vector, w, and they are all on the same plane, meaning they're lying on a piece of paper and nothing's coming jabbing out at you. And the angles between u and v, as shown here, is 38 degrees. The angle between u and w is 109, and what that means is that there has to be a 71-degree angle here because 38 and 71 is equal to 109. And I want to sketch the vector r, which is made up of 3 u's, 2 v's, and 4 w's, so no negative, no opposite directions this time. And then I want to find the magnitude. There's those bars with bad spelling. I want to know the magnitude of the resultant. So I have to draw this picture. So the first thing is, I don't know if you can tell, but my W is terrible. It is not the same length. All these have to be the same length for it to be unit vectors. So I am going to make a unit vector here, and that's U. And apparently I need 3 of them. So as long as I am within the realm of having it the same length, I should be okay. So there's my first one. There's my second U that's necessary. There's my third U that's necessary. This is almost easier on paper than it is on the smartboard. Then I have to veer off with 2 V's. Not what I meant to do. And you can see I got a little bit longer. And then I need 4 W's. So the first thing I want to do is I want to take this stuff and stick it together. Otherwise it's going to go all haywire. I'm going to pull it into a different spot, and now I'm going to draw my 4 W's. So I need a W going in this direction. 1, 2, 3, 4. Not like that. Like tip to tail. And again, I'm out of room. Glue. All right, so the resultant is the shortcut, which I will turn blue for fun. So here's the trick to this question. A couple of tricks. So first of all, these are 3-unit vectors. So even if I didn't draw them as accurately as I could have, they're all 1 unit long. So what that means is that this side of the quadrilateral, 4-sided figure, is 3 units long. This side is 2 units long, and this side is 4 units long. What I'm looking for is how long is that? Another thing we can do is we can find angles here. So, and I'm going to doodle a little bit, but if I extend that side, that's my U measurement, and the degree measurement between U and V is 38, so this is 38 degrees, which isn't all that helpful because it's on the outside of the quadrilateral, but it means that I can do 180 on a straight line minus 38 is equal to whatever that happens to be. Don't judge, it's Sunday morning. 180 minus 38, 142. Excuse me. And that's the number I'm after. Next one is if I extend my V's, the angle between V and W is 71 degrees, so I can do that very same math. And get 109. That is a bit of a coincidence with this 109. All right. I'm just contemplating whether to leave the yellow on there and mess it up. I think I'm going to get it out of there. Give me a sec. I'm going to pause it and I'll come back to you. Okay, sorry about that. I was hoping I wasn't going to erase anything and then embarrass myself publicly. Okay, so what I can do now, and I'm going to do this aggressively with this very thick red line maker, you have to make triangles because the only thing you can do with this is triangles, because what we're going to use now, in addition to grade 9 math, where you learned how many degrees are on a straight line, how many degrees are on a triangle, how many degrees are here, there, and everywhere, we have to reach back to grade 10 and 11 where we had the sine or cosine law. So we have to make a triangle. So we can make a triangle there, so we'd have a lower triangle and an upper triangle. But my preference is to draw a triangle here, only because my spacing is a little bit better. This is not a vector. It doesn't have to be a vector, because right now we're worried about lengths of line segments, not the vectors themselves, because this, even though it's associated with a vector, it's magnitude, so I'm just looking for numbers. So I'm going to get rid of that aggressive red line, and I'm going to put in a normal size one. Now, there's something to be said for me doing this or the other version, and that is, either way, you have to split an angle that you've just found. So I have to split this 109 if I'm going in that direction. So part of this and the other part of it add to 109. Again, I'm not choosing that triangle because it's skinny and I won't be able to put all my stuff in. But in this triangle, I've had to mess with this angle. So both sides of these angles add to 142. I'm going to more centrally locate that. But I don't know what any of them are. And if you're thinking that this looks isosceles, remember this is very much a sketch, so don't go thinking that kind of stuff. So here's the difficulty. You have to start where you can. And by that, I mean you have to know your sine and your cosine laws well enough that you know what to use when. So if I'm going to label these triangles just so that I have good communication skills. So I'm going to label this with A, this with B, this with C, and this with D. Okay, totally arbitrary. And if I look at triangle ABC, so this one here, the thing about triangle ABC is I only know 3 on this edge. I don't know this. This is what eventually I'm looking for. I don't know this. I don't know this angle. I don't know this angle. I don't even know this angle. I only know that it's part of 142. So this is a very bad place to start. Triangle ABC won't help you all that much. But triangle BCD will, because triangle BCD, I don't know this angle. I know it's part of 142, and that's not good enough. I don't know this angle, but I do know that this side is 4 units in length, this side is 2 units in length, and this corner is 109. Now this is, for those of you who were in my grade 10 class, this is a very excited bobblehead doll. This is, and I'm going to write it here, and I'm going to do it in red. This is for triangle BCD, and because I've got a side and a trapped angle, I have side, angle, side, and whenever you do side, angle, side, that leads you to do the cosine law. So the cosine law lets you find this side right here, which I'm going to call D because it's across from big D. Unfortunately, it's got a double label. It's also A in this triangle, but I'm worried, I'm focused on this triangle right here. So the cosine law will be D squared equals B squared plus C squared minus 2BC cos D. And hopefully you remember from grade 10 and grade 11 that these two have to match, as in whatever letter is sitting here, this has to be its, I don't know, corresponding angle letter. So I'm going to get rid of the green and start plugging in values. So D, little d is unknown. Little b is across from big B, so that's the 4. Square it. Plus C is across from the big C, so that's the 2. Square it. Minus 2 is always in the formula. There's B again, so 4 again. There's 2, so C again, and cos D, angle D is 109 degrees. So make sure you have your calculator on degrees when you're doing this. I'm going to dig out my calculator and I'm just going to pile it all in. And hopefully you were told in grade 10 and 11 that you don't have to show much work. You just have to make sure you type it in properly. So 4 squared plus 2 squared minus 2 times 4 times 2 times, for me it's 109 cos. Make sure you don't hit equals until the very end, and that is the value for d squared. So that's 25.20909. Not that it matters all that much, because to be honest, I'm going to leave it on my calculator. And that doesn't make any sense. As I would have said in grade 10, it doesn't make any sense that one of the sides is 4 units in length, the other side is 2, and this one is 25. Don't forget that you're not looking for d squared. You are looking for d. So that means to get from this line to the next line, you have to hit the square root button and get 5.02. And this is 5.02 unknown units. And just because you might be rusty, boop, I square root it. So I'm going to take that 5.02 and I'm going to write it on the picture so I don't have to keep referring back to my work. So the reason I found that is, number one, it's the only thing I could find. And the second reason is now I have an actual measurement that's on this triangle. So I'm getting closer to the blue line, which is R, or the blue vector, which is vector R. The thing about this is that now I have two sides, but nothing else. So I need an angle. So it would be kind of nice if I could do the cosine law again, in which case I need this angle. The problem is I have no way of finding this angle in my blue line triangle, but there is a way to find this angle and then subtract it from 142. So I'm going to do this first. And that, now that I've got partners, now that I have two opposite pieces of information, I can find this opposite piece of information, and I can now do the sine law, because the sine law is when you have opposite pieces of information. So stop scribbling on this. And I'm still in this triangle. So I'm still in triangle BCD. And I've got sine big B over little b equals sine big C over little c equals sine big D over little d. And I'm going to need to use this part because I know all the D information and I care about the B information, so this is useless to me. I could find it, but it's not going to do me any good. So sine big B, because that's what I'm looking for, over little b is this one, equals sine big D is that 109 degrees, and little d was the 5.02 that I just found. So to find me sine B, I'm going to take 4 times sine 109 degrees, so I'm cross multiplying. I would cross multiply this, so 5.02 could sit here, but eventually I would just have to divide by it anyhow, so I'm going to divide by it right now, and I'm going to get probably something ugly. 4 times, for me, 109, and then I have to hit my sine button. Don't forget to have your calculator on degrees. And then I have to divide by 5.02 equals, I get that. And that is not how big B is. That's not the angle measurement. It's not 75 degrees. It's not 75%. It's sine B. So reaching back into grade 10 and or 11, I need to do second function sine to get 48.9 degrees. And I'm going to put that in the picture. And no, there is no easy way around this. Okay, so I now have more measurements in my right-hand triangle when really I need to solve a problem in my left-hand triangle. So what I'm going to do, and I'm going to do it here in blue, and then shift it down so we can see it. I'm going to take 142, which is this whole measurement, and I'm going to minus off the 48.9 to find the other B angle. Oh, it joined. Yay me. And then I'm going to put it in the picture. Calculator. Oh, so minus 142. Yes, I minused backwards, and I get 93.1 degrees. And that's a positive 93.1, despite what the calculator told me. So now I'm in the left-hand triangle, and I'm doing everything in blue. So now I'm in triangle ABC. So when I labeled this, I didn't actually label it arbitrarily. I labeled it so that this triangle was ABC, and this triangle was BCD, so it had some order to it. So here's the deal. We need this value, and if you can see, there is another cosine law situation here. I've got this side, which is 5.02. I've got this side, which is 3. I've got this angle, which is 93.1. So that, for those of you who are in my grade 10 class, is the very excited bobblehead doll. It is also more affectionately known as side angle side because the angle is trapped right between the two sides. So I get to do the cosine law again. Let me just back up this yellow and write what I want to do. So I'm in triangle ABC. It's side angle side, which makes it the cosine law again. And guess what? We're done after this, which is kind of nice, because we'll have R, because the cosine law lets you find the side that's opposite the angle that you know. So R is actually B. I'm going to keep calling it R. This is 5.02. This is C, which is 3. You can label it or you can leave it unlabeled. It depends on how you want to deal with it. So I'm actually looking for little b. So I'm going to write this officially. My choice. Little b squared equals little a squared plus little c squared minus 2, always, ac times cos big B. This letter corresponds to this letter. All the other ones fall in between. Starts very Pythagorean theorem-like. So b squared equals, so A is across from big A, so that's the 5.02, regardless of what it's labeled. Square it. Little c is across from big C, so that's 3. Square it. Minus 2, there's A again. There's C again. Cos big B is this corner, so 93.1. That's why we had to go through all that trouble. And then I'm going to type this into my calculator. Good thing I can see everything. So 5.02 squared plus 3 squared minus 2 times 5.02 times 3 times, for me, 93.1. Hit the cos button. Did not hit equals anywhere until right now at the very end, and I get 35.829. And that is not reasonable because I'm not looking for b squared, I'm looking for b. So while that's on my calculator, however you do it, I have to take the square root and I get 5.98 blah blah blah. So that is actually 6.0 when rounded to 1 decimal place. So therefore, the magnitude of vector r is equal to approximately 6.0 units. And actually, I'm going to take it off of there and write my therefore statement properly there. So that's how you go around a picture that is not a triangle. Remember, this original picture without the line drawn in between is actually a quadrilateral, a non-special four-sided figure. Okay. So that's a pretty big application. Thinking question. Requires you to remember some things that are absolutely necessary from grade 10 and 11 and even a little bit of 9. So remember when I said in advanced functions you need to know everything you've been taught in math before today? Same thing with calculus. All right. There is the work. Remember that you have had all the blank notes online if you choose. Anyways, that is all.